Okay, good afternoon, everybody. Once again, welcome to our IAQ Matters online workshop, Recovering HVAC Efficiency Post-Pandemic, How Optimal Maintenance and Operations Benefits Energy and Indoor Air Quality. I'm your host today, Troy Raszka, the Director of Marketing and Communications, and with me, I have Waverly Wooding III and Louis Theberge from our Building Sciences Division here at WTI, Pure Air Control Services. And they do a lot of T&B work, test and balance work, HVAC assessments and performance metrics for our company when we start to look at HVAC systems and how they affect indoor air quality. As we know, the COVID-19 pandemic brought in a lot of new guidelines and recommendations for operations, particularly from ASHRAE, and then they were adopted by the Centers for Disease Control, and then distributed to buildings and operations managers on both how to operate when the building was closed during pandemic time, and then as occupants started coming back into the building, they gave a different set of guidelines on what we would want to do to keep the buildings clean and ventilated for optimum safety of the occupants. And so today's workshop is going to sort of address how to get back to good energy efficiency, good operational status after implementing all of these new guidelines. So today's program is going to take a look at specifically these guidelines, right? The increase of outside air, increase of air change rates, the recommendations for higher efficiency filters, and then how to get back or balance this sort of new state of operations with where we need to be for optimal performance and to try to start to get this energy back. And this is going to look at BAS systems, getting back to set points, commissioning your VAVs, energy assessments, looking at the HVAC conditions, then the air conveyance system cleaning to make sure that inline equipment is operating at optimal efficiency and performance, taking a look at how to achieve more efficient airflow outside of the existing equipment, and then we're going to open it up for some questions and answers. Today's format is just, it's going to be conversational. It's going to be very high level because we invite a large variety of folks with different expertise, and so we don't want to talk at too high of a level, but we're not also going to dumb it down to the lowest common denominator either. So we're going to try to strike a balance, very high level overview of some of these concepts. And as always, we're open for questions. We're open to take the conversation offline and talk to you personally in one-on-one calls or through email chains. We're always available to answer questions. We live for this stuff, indoor air quality, HVAC efficiency. We're going to take sort of a format of a pro and con approach to some of these new guidelines, what it did to energy efficiency within buildings, because as you know, the last 10, 15 years, we're focused on airtight buildings. We're focused on achieving optimal energy efficiency through building systems. And a lot of that quite literally went out the window with these new guidelines. So Waverly, why don't you sort of take us through a little bit of what these guidelines suggested to make the building safe for occupants, including bringing in more outside air, flushing the building, what that kind of meant, and then sort of you guys can bounce it off each other, what the benefits and maybe what some of the downside of this was.
Sure, fantastic. Why don't we just start off with the segue that you gave us about the outside air increase in buildings. It was entertained and suggested that a flushing or a dilution of the air concentration in buildings take place during the pandemic. And the easiest way for building owners and managers to do this would be actually to go straight to the unit itself and allow for outside air increases at said air handler unit. This was done to add to the amount of fresh air that was introduced into the building. And one of the other things that was gained by doing this was the building pressurization. If it wasn't already positive, it definitely was now after this change was made. So it was a practice that was grabbed just about by everybody in the medical field. And some of the things that we saw after this, I think Lou's going to allude to right now.
So now we just increased the outside air tremendously to flush out the building for the COVID-19 situation. And now we've increased the debris and sediment building up on our filter medias. So that's going to require more maintenance in order to change those out and loading up on both the pre-filters, and hopefully it doesn't damage the after filters. Then we also have an increase on the cooling coil. If you didn't have the right amount of chilled water before and you're suffering on capacity, well, then now you're really going to have a problem because you can't take the heat out of that air that you just increased.
Yeah, if you can't take the heat.
Can't take the heat, get out of the kitchen.
Exactly. So in some ways, the con of bringing in more outside air, the downside would be not only if the system maybe couldn't handle better filtration, and I know we're going to kind of get into that in a little bit, but if there was deficiencies already in the equipment, filter bypass, things like that, it could actually load the coil with more latent debris, which could create an insulating effect, right? And then
yes,
you're also
sure.
talking about the actual like the operational load or the physical load on the entire system for maintaining set points. Is that correct?
That's correct, because coils are designed to handle a certain volume of airflow at a certain temperature. And whenever you change set points to increase that load on the coil, you could see now in some cases, a disastrous effect on your ability to keep your building cool.
Right, and then so in turn, what would happen is that maybe the system would work, and we're going to kind of sort of talk through all of these points point by point, but in theory, I'm just trying to set it up that the equipment would work longer to maintain the desired set point, which would essentially mean more energy consumption.
Yeah, I think we both agree on that that is a large, expensive or a choice to make. We understand that this was made during the pandemic, and we were all trying to do the best for one another. But now that that's, I hate to say it's said and done, but now that we're talking about getting back to where we were as far as building operation is concerned, a lot of buildings did realize that they didn't have the ability to cool the way that they thought they did after this increase was made. So going back and allowing people back into buildings is actually a segue into getting things back the way they were prior to. And that's primarily what we're here to discuss.
Yeah, no, I got you. So with the increase of outside air, one of the other main objectives were to increase the number of air changes per hour. So why don't you take us through that? Maybe even explain how a healthcare environment, right, a hospital, a surgical suite, an intensive care unit might have had one standard for air changes, while an office building or residential environments might have had a different one, and then sort of how these sort of coalesced with one another, again, to try to keep air moving through the building so that there was no, COVID particles or other particles lingering in the air for too long.
All right, as we found out that quickly, we found out that this particular virus was being spread airborne. So we knew that it was an airborne virus that we needed to focus on diluted concentrations of air in buildings, because the more congested the air, for lack of a better term, would get, the CDC mentioned that that's probably the best chance for us to actually contract SARS-2, which would actually make your body react a certain way, and that was actually called COVID-19. So, and just an example, operating rooms that used to operate at 12 air changes per hour stepped up to 20. That was a lot of load on the coil, but they were really diluting the air concentration so that there was more fresh air than contaminated air, for lack of a better term, in the airstream that we're actually breathing. And by doing such, we're diluting that air concentration, we reduce the chances of contamination, or at least that was the theory behind it.
Right. So again, with anything where you're switching the standard or the mode of operation, there is some cons to doing that, or the things that could have affected energy efficiency or what quote unquote normal operations. I mean, Lou, do you have something to add on that side, especially with air changes?
Well, with the increased amount of air changes, you're going to positively pressurize the space, especially in hospital environments. And you may have an overpressurized space where the doors will not close. When you have fire alarms and the doors close, they may be so pressurized that the doors actually won't lock and close with when you get those alarms as well.
And Waverly, you did just mention as well, once again, that there's an increased load on the coil and the system. Like I was alluding to earlier, that it's running longer now to achieve set points. It's staying on longer too. I mean, even if it wasn't, because of the outside air, now you're actually running more air changes. So it's almost constantly running. I mean, is that a fair assessment at 12 air changes an hour? Holy mackerel.
Yeah, and almost doubling that meant that load on the coil, and you'll hear that word quite a bit as we discuss these things. That load wasn't really discussed. We were really in scare mode. We weren't sure how to take care of this, but we did know that if it was an airborne situation and we diluted the concentrations, that things would get better. But unfortunately, I don't think much concern went into the building owner or management when it comes to energy efficiency when you're putting that much load on a coil. So once again, now that we're scaling back, putting things back to where we would like to consider to be normal, now people are seeing that their energy bills definitely went up during this period. And it might actually open up the door for other investigations like some of the things that we offer.
Yeah, no, that was kind of going to mention that in passing, and which is also a good segue into the next topic. But let's say that a building didn't adhere to what ASHRAE was saying and just put everything on setback for a year. I mean, think of the kind of issues that could cause. They might be saving on energy, but now when they go to reopen the building, or when they went to reopen the building, there was a host of other issues that was going on within these systems and the occupied space. So that is a good point as well. I think that really what we're talking about is, as we start to move through the rest of this presentation, is we're going to have to strike a balance to get back to some of the best practices for energy and operations for HVAC. But we also want to make sure that the systems are running optimally, so airflow is still maintained and at probably a more increased rate, right? And that there's a balance to be had. So obviously another thing, speaking of indoor air contaminants, speaking of bringing outside air in and mixing it, is the need for increased efficiency air filtration. And efficiency here, we're not really talking about energy efficiency, right? We're talking about the ability for the filter media to actually do its job and capture the different particulates and debris that might be coming through the system, whether it's being returned to the system or brought from the outside. So why don't you take us through and discuss a little bit about the impacts of this higher rated filters being put in systems?
That's a great topic. The medical field has been aware of this for quite some time, as far as the size of the airborne contaminants that we did not want in our airstream and in hospital situations. Excuse me. So they've been using HEPA filtration for quite some time, and that HEPA filter will remove particles that are 0.3 microns or larger in size, and we find viruses to be and bacteria in that range. So if you're using proper filtration or filtration that is as good as HEPA, then you would be reducing your amount of contamination. But as Lou will tell you, all good things come with another avenue to look at. And tell us about some of the bad things that could happen with HEPA filtration if you add it.
Exactly. Well, first off, you're going to have an increased static pressure on the total system, the fan, and the discharge of the unit. With the higher filter loss, your static pressure discharge is going to go up. Means your fan is going to have to run more. So there's added expense in that. Second, they're not cheap to replace. A regular HEPA filter, 99% filters around the $250 to $300 range. And sometimes you have a bank to 10 to 12 or 20 of these things on the discharge of a unit. You do have pre-filters that you must change regularly to keep the efficiency integrity for these HEPAs. So that's the first thing you need to do, and that's expensive as well.
Now, do the pre-filters, they would tend to maybe catch the larger particles and debris that's coming in, and would they fill up faster or be used up faster than the HEPA filter? That's sort of their intention, right?
Correct. Yes, that's to keep the change out of the HEPAs down. Yes.
And then, you know, and I think we've discussed this in past workshops, you know, or maybe touched on it. But two things with these higher rated filters. Is there anything that has to be done to the operation of the system? I'm a layperson, I'm not an engineer, but is there anything that has to be done to the system to sort of offset? Is there an airflow obstruction with the more, is dense the right word, or the more, you know, the more rated, the higher rated the filter, does airflow suffer just inherently because of the higher rated filter, or am I way off base?
Well, for a regular HEPA filter, you normally start off at a clean filter rate of 1 inch static loss. That's clean. And then they load up to pretty much 1.75 would be the limit before they start losing their efficiency.
And then, of course, as again, they start to capture all of these different particles and begin to get dirty, right, or fill up, correct, then airflow also has a chance to go down.
They let more particulates out.
Yeah, as it's capturing more particulates. So then what we have here is sort of a paradox, right? If we're asking for an increased airflow, more outside air, and now higher filters, it's almost setting up a perfect problem where if you're not keeping an eye on this filter media, it might be actually doing the exact opposite of the intention, right? Where now it's filling up quicker and airflow is actually being obstructed, which impacts the performance and energy use of the system as well, right?
Absolutely.
Correct.
Now, one more thing before we move on, and that's actually somewhat of another segue into the next topic, but what happens if the system isn't designed for the higher rated filter and the facility manager or the stakeholders in the building management team say, well, this, you know, they're saying put these MERV 13s in, let's just slam them in. What in theory could happen to a system that's trying to run filters it's not rated for?
Well, you'll definitely add restriction to the system. I mean, that's technically how a filter works. It is filtering out particles from the air, but that creates restriction. If your system cannot handle or operate under said restriction, as we know it as static pressure, you could be increasing so much static pressure that you lose performance on your unit. So yeah, you're filtering, but you don't have the ability to remove heat the way you used to in your building, nor do you have the ability to maintain the pressurization requirements that your building might have needed to begin with.
I gotcha. Yeah. So again, that's something to keep in mind, that it's not one size fits all for these filters. You have to definitely double check the specifications and design of your system to see if they can even handle them, or you're going to have some serious problems probably down the road, which affects this condition, right? You know, how the system's being programmed to interact with the building and the other systems in the building. So maybe take us through what kind of changes were made to set points to accommodate the outside air, the air changes and the filtration, and then how we want to maybe put those back, or again, balance them to a happy medium to start to realize energy savings.
Right. So, well, the good news is all of these cases were actually designed by professional engineers. So the set points that originally were held by a unit or maintained by a unit can easily be brought back to their original design intent, which will get your building back to where it was. So some of the things that took place when these set points were, let's just say, temporarily adjusted for the pandemic was, one, an increased air volume overall into the building. Two, or I should say adding to that, would actually be an air change per hour increase, like we suggested and discussed about in operating rooms. And all this combined actually was a big intent to actually reduce the CO2 which the CDC discovered that obviously when CO2 levels are high, it's usually because there's too many people in a room. And with an airborne pathogen that we're trying to stay away from, the CO2 levels reaching higher limits were actually good indications that maybe there was too many people in that room or more air changes should take place in that room. But of course, with any change or any action, there's an opposite or equal reaction. So Lou, what were the cons to bringing all this air in?
We know the operation of the system outside the intended design was done, but now we're all trying to bring it back. We've touched on the increased load to the system, but the biggest thing is downstream of the system that nobody really looks at is what happens to the ductwork and the VAVs and the CAVs at this point. We don't know beforehand, unless a pre-evaluation of the system was performed, how they were operating to begin with. Now we could have problems brought on from things that just don't work correctly, and the static pressure has changed. So now you have to increase the static pressure, and it's just it can involve a lot of things, bringing a system back to normal again.
Yeah, no, I hear you. And so even as you're looking at that it reveals pre-existing problems downstream, VAVs and valves, that's a good point. Like when we start talking about VAVs, right? I mean, maybe explain to us, for the lay people, what a VAV actually is, what it stands for. We hate to be redundant to those of you who are engineers and operate, or mechanical engineers and operate at a high level. Maybe explain to us what that is, what it does, and then how they get fouled because of these new operating conditions.
Sure. Okay. Well, a VAV is a variable air volume device. It is used to increase or decrease desired airflow or volume into a space. VAVs usually operate to a temperature set point, and they're usually calibrated by a professional to maintain a max airflow or a min airflow, or a heating max airflow or a heating min airflow. These are standard operating points for a VAV. Commissioning is a word that is definitely mentioned here on this slide. We like to use the word. It's kind of like a review of said equipment. No one opens up a new building where the public is invited to come in without this equipment being checked out prior to. But we found with experience that as years go by, these actions aren't taking place anymore. And then when we actually decide to make set point changes in a building like we just did during the pandemic, unfortunately, you start to see, I like to call them sores, and the Band-Aids are getting ripped off as we actually go through and inspect these VAVs. We're finding out that little things were done that were less expensive to kind of minimize negative temperatures obtained in the building and complaints. But when we commission VAVs, we check all the points of the VAV. So opening and closing is checked out. Whether a valve is stroking all the way or part of the way would be found. And like we said about the issues, another issue is when the flow rings that are measuring the airflow as it travels through the VAV. If these get loaded up with dust, it will actually give false information to the system and actually create the VAV to or cause the VAV to act in an opposite manner than it should be. And these type of things can steamroll into major problems in a building if they're not paid attention to. But the good news is, if you're taking care of this situation during a post-pandemic situation where you're thinking about letting people back into the building, this type of work can be done while the building's at minimal occupancy, and staff wouldn't even realize that this type of extrinsic testing was taking place.
Yeah, so we could do it on off business hours to be able to take a look at this equipment. We're not going to disrupt the normal workflow of the school or the hospital or the employees in an office, which is good. And then, I want to mention here, and then we can kind of talk a little bit. You see the bullet points on here. But, when we look at energy consumption in a building, the last stats that I checked was that the HVAC system takes up like 60 to 68% of the energy consumption of a building, even over lights and computer equipment and other systems in the building. Now, I realize, even again as a layperson, and you can chime in here, guys, that a lot of this is at the chiller. But the other thing to consider is that it's a holistic system. So even all of these little things, say there's 100 of these things throughout a zone or an occupied space, and if these are operating in a deficiency, it could kind of create a domino effect, back from these to the coil to the filter, all the way down to the chiller. Am I wrong in thinking that that would be the case?
No, you're absolutely right. It even goes further than the chiller. What about the cooling tower that's actually removing the heat from the chiller? You were spot on before. To my knowledge, as far as HVAC equipment, the chiller is the most expensive thing to run in a building. So making sure that all things associated to said chiller are running efficiently would be the key to get a better efficiency out of your system to begin with.
Yeah, that's a great point, and I just thought it bared mentioning here, even though we're not showing the whole interactive system. We're sort of talking about sort of the front end, right? Of the system, and not the bookends, right? Or maybe it's like the middle, right? You have the chiller in the basement and the cooling towers outside or on the roof, but this is all the stuff that immediately affects the occupants. And that's sort of the name of the game for WTI Pure Air Control Services. So when we look at maybe the downside of what we would call commissioning the VAVs or inspecting the VAVs, and I might add ASHRAE 62.1 for calculating ventilation rates for optimal IAQ actually has a whole section on inspections, maintenance, and commissioning, and certainly this equipment is part of it, to be able to keep an eye on this stuff on a regular basis, if not annually, maybe 2 times a year, looking into this type of equipment. But what are the downsides of actually doing this? Because it all sounds like it'd be a net positive.
Well, it is time consuming. You have to go to a VAV or CAV per instance, and you have to bring in a controls contractor in case you have other issues, unless you can manipulate the systems to do what you want it to do minor repairs. After that, then it could be a board or something else like that, or an actuator that would need to be replaced.
Right, so it's sort of like the old adage that we use a lot, how can you manage what you don't measure? So if it's out of sight, out of mind, what happens is a lot of the facility management team and engineers are just putting out fires. They're waiting for something to fail before they actually address it. And now the pandemic has probably exposed a lot of these deficiencies because there's been some time on folks' hands, because there's been a heightened awareness of this type of equipment and how it affects the building and occupants. And now, even especially for schools, there's funding to actually have this looked at and addressed. So, in my mind, a lot of what we're talking about here is just a net positive. It's an investment for the future, and to keep these systems running and clean and optimal for the safety of the occupants. And so now, once we start to put all of these pieces into place, and we look at what these recommendations were and how we're looking at maybe what the downside of some of them have been, and what we can do to get back to strike that balance to better energy efficiency, we come right down to actually looking at what these systems are doing to the bottom line energy bill. Is that right?
That is absolutely right. It could look from the front end computer, or the energy management system, as some people call them, that everything is fine and dandy until you get your electric bill. And then you're trying to figure out, well, why are we so much higher than we've been before? And it kind of alludes to one of the things that Lou just mentioned on the con side. When you evaluate your system, you start to find deficiencies. These deficiencies add up. I'm not gonna embarrass myself by trying to remember the dollar amount that was applied to this saying, but I was told a long time ago by a wise man that a single drip in a mechanical room that goes unwatched could add up to thousands of dollars. So knowing where your energy is going and knowing whether or not it's being used correctly and efficiently is one of the things that an energy usage assessment could assist you in. And as far as the future, if you're looking at energy savings, or trying to run your system more efficiently, there's really no better basis than to understand just how much energy your system's using up front.
So typically, what does an ESCO or an engineer do to conduct an energy assessment like you're talking about? Like what, and again, it's a very high level, but what types of devices, what readings are they taking to sort of start to get that data and to be able to look at making those ROI calculations?
Well, I'm going to take advantage of the slide. These little devices that you see in the bottom right-hand corner of the graphic are actually what they call current transmitters. So that CT would actually be clipped on your phases of electricity. And the little black box is actually taking that data and logging it. So you can actually see usage for upwards of years if you needed to. But in most cases, a month or a season or a year is more than anybody will need to do a proper audit to determine how much energy usage they're actually going through.
And then something like this, which is a higher level study than what we typically do at WTI Pure Air Control Services, but something like this could be useful for a set period of time before and then after service contracting to clean a system, to maintain the system, if you really wanted to get a clear picture of the ROI of bringing it back to a state of efficiency, right?
Agreed, and it's pretty much the last phrase in that pro section. It's the basis for all real return on investment calculations. You need to know where you start. It's your foundation, and then after things are done, you can compare it again to your foundation. And that's when the reality sets in that savings was made or energy usage is efficient.
Yeah, and not to steal loose thunder, but it looks like this could be a costly endeavor as well. But I'm sure that, and I haven't done this because we're not on the energy side, like specifically. You know, we're more on the performance and retrofitting side and the environmental side, certainly for indoor air quality. But it sounds like this could be pretty costly. But again, I would imagine that there's tax incentives and rebates and things like this through power companies that can help defer some of this cost because the organization is taking the right step forward to be more energy efficient. And as we know, we're all moving to a greener society. We're trying to make energy efficient buildings that have the balance of also creating a good indoor environment for people to live, learn, and work in. So, I would imagine, again, when we talk about these things, these are an investment, and that's why we look at the return on that investment. And again, I know many of you that are on today with us as guests, and we thank you for coming on, are energy contractors. We know still that many of the larger school systems, public universities have their own energy contracting teams that keep an eye on this kind of stuff. We've worked with them over the years. And so I think that, to kind of reel it back in and bring the energy back into this now that the pandemic has subsided, or maybe it hasn't subsided to the extent that we would like it to, but we have a better understanding of where we're at with how the pandemic has affected indoor environments and the systems that are used to keep them optimal. So beyond an energy assessment, when we start to get into the territory of things that we do, and we've touched upon this in a variety of the presentation material today, is that we want to actually take a look at the conditions of this equipment, not only just the VAVs, but again, working backwards back to the actual air handling units and the air conveyance system ductwork. We want to know what conditions these are in, right? So a lot of the pandemic, we certainly spent as a company with different customers that were taking advantage of the buildings being closed to kind of go in and really do a deep dive into the physical, the performance, and the environmental conditions of this equipment. Because if you're going to be recommending bringing in more outside air, if you're going to be recommending more air changes per hour, if you're going to put higher rated filters in, can the equipment actually handle it? Or are you just looking at a perfect storm and a disaster within the building? So guys, why don't you take us through, because I know you do a lot of these for hospitals, universities, commercial clients, but what are we looking at when we're assessing the conditions of air handling units?
Well, primarily visual. I mean, it's the one tool that we were all born with. Well, not everybody. I pardon myself for that one. Stevie Wonder might have an issue with that. But the reality of it is visual conditions will tell you a lot about your system. I tell people, look, use your eyes, use your nose. If it doesn't look right, doesn't smell right, it's probably worth calling in a professional to take a look at. We take it one step further, in some cases 2 or 3 steps further. But environmental sampling is also involved. When we look at the hygiene of a system, we will literally take surface samples on areas that the air passes through, whether it be the coil or the inlet of a fan, or actually the discharge ductwork going downstream to serve a building, and take surface samples and send them to a laboratory and have results come back. And then we would write a report based on those results. Besides that, we also do performance testing, because you really can't tell someone just by looking at their system that it's not performing correctly.
Yeah.
That does answer the question for hygiene, but you don't know whether or not your CFM values are within the design intent, or even your GPM value flows through your coil could be below design. And a performance test would bring all that to fruition. And that's just at the air handler. I think Luke can actually add to some of the things that are done downstream of the air handler.
Well, we're going to inspect the supply and return ductwork. We're going to make sure the dampers are all operating correctly on both sides, both ends of the spectrum. Heating coils, a lot of those, they get plugged up. They may have to be cleaned afterwards, along with the cooling coils and the unit heating coil. You just take a summarized approach to a system, piece by piece. We believe in data, a lot of data, and that's what we work in. That's our field.
And actually, to actually even sum that up a little bit further, we have found that people actually use our reporting as a basis to allow their HVAC systems in the future to run more efficiently. And that sounds a little bold, but when you think about it, if we're detailing with photographs the conditions that we found, if we're backing it up with laboratory results on what was found on said surfaces, and we're actually detailing the model number, serial number, belt sizes, shift sizes, number of filtration devices, the efficiency of said filtration devices, all of that gets categorized into a list that we provide for our clientele, and it basically prioritizes the maintenance and the restoration if you have said need to your unit. So for lack of better words, it's kind of our report can actually be a good, better, best situation to give you an idea of what would be next in line to kind of like that. What would be next in line to actually restore, and where your concentration should go with your financial or fiscal responsibilities for the system.
Yeah, so this is a very high level summary, and what we have found, our customers love it, because we will go into, let's say, a large university or a medium-sized even, state university, and there might be 4 or 5 different HVAC managers that manage different parts of the campus, and their data themselves is incomplete. And I don't want to indict anybody here, but they're all doing it in different fashions. There's some turnover in that environment, so we will come in if there's an issue, or a higher level stakeholder like the board of directors are saying, hey, this COVID, we have to focus on this. What are our air handler units doing? And they don't even have prints. They don't even have the actual inventory. So what we have found is a lot of stakeholders will use these high level assessments and they'll actually build their inventory out of it. And at the end of the day, now they have a highly detailed inventory of a snapshot of a state and time of all of their equipment. And now they can make this plan and move forward. So this would be like what an executive summary page within the report would look like after hundreds of photos and lab reports and things like that, but it prioritizes the need for these systems. And just because a system is old, 20 years old, 15 years old, doesn't mean it needs to be replaced. By looking at it and this kind of detail, you can say, okay, well, 5 of these units need to be replaced across the whole inventory, but we can clean up and restore the rest of them for huge capital savings and get them right back in line with how the systems were designed to operate. So this is a very useful tool that a lot of our customers just love. And then I'll also add, before we move on to some of these prescriptive recommendations that these kind of assessments provide, is that in this age of multiple rounds of funding for COVID relief, and as the focus for this funding has come into sharper view, right? So the language in a lot of this funding has been sharpened to include indoor air quality as a criteria, HVAC equipment maintenance and replacement as a criteria. Now, this kind of reporting gives you accountability to the actions that you're taking with this funding, right? So now, if there's any compliance issue or there's any audit issue from the federal government to check up on how this funding was spent, you will have a very detailed summary of everything that was looked at and now the actions that are being taken with this funding to improve your school, your healthcare environment, nonprofit, anyone that's getting this kind of funding to address indoor air quality via the air conveyance system. And so, again, these reports can sort of take and summarize and then make recommendations like we're talking about here with cleaning the air conveyance system. So, what goes into that, guys, when we look at cleaning the air conveyance system?
Well, we start with the air handler itself. I mean, that's where the fan is housed, and that's how air is moved from point A to point B. But as it goes and leaves the unit, it goes through the ductwork, and that's one of the things that unfortunately I see in my experiences in HVAC that kind of goes just doesn't get the attention that it should. I've even heard requirements that ductwork should be cleaned every 5 to 10 years in the building if the building can afford to have it done. But it's I'm not going to take away from the cons, but I'm going to focus a little bit more on some of the pleasurable things after we have seen air conveyance system clean. It's definitely more hygienic. You can literally smell a difference in the airflow. When the airflow is better and smells better, the occupants in the building, I've heard lots of testimony, it just is better to be here because our sinuses aren't bothering us, or we're not having allergic attacks because of dust buildup. It just equates to a better indoor environmental quality. And the other thing is it does reduce static load on the system. It takes a lot of buildup to really affect the static load on a system. But we've seen some that would definitely go in the memory books and memory banks that were so foul that it was definitely negatively affecting the performance of the system.
Yeah, for sure. And obviously it takes time to do this, especially if you have long runs of ductwork and everything. But again, the good news is that we can come in when the building's not occupied and perform this kind of work because we are environmentally focused. We're going to do this work at a bit of a higher level. We are going to take particle readings. We're going to make sure there's no cross-contamination, all of that good stuff. And of course, with air conveyance system cleaning or any of these post-diagnostic services that we come in and do the remedial work, you're going to get a full report, almost just as detailed as the assessment, showing the before and after results. Again, this is great for compliance and reporting when we're looking at using ESSER funds or just having it to present to stakeholders. So that's pretty remarkable stuff as well. And then, the other thing I'd like to mention as we start to wind this down and start to look at other methods of getting more efficient airflow control in conjunction with this cleaning and restoration piece is that we've attached an archival article from David Burr that was in Energy Services Today. It's in your handout tray that you can download and read, or go to our website under resources and read it. But he refers to a lot of the stuff that Waverly was hinting at as non-energy related savings that still go hand in hand with the notion of creating a sustainable building, sustainable systems. And so when we look at happier occupants, right, we're not even just talking about their emotional well-being, but we're talking about the bottom line for the company, because we know there's been, I think the Harvard cognitive effects study is in round 4 right now. And this started way before the pandemic. And there are calculable results that show improved cognitive function, less downtime for employees, less absenteeism, right? And so this all adds up to a better bottom line for the company, not to mention creating a more sustainable program to operate this equipment, where we're talking about upcycling equipment, repurposing it or refurbishing it, as opposed to just junking it and buying new. So these are all extra incentives beyond just the straight bottom line energy bill that a company, a university, a public school system is going to realize out of assessing this, taking the data and actually doing something with it. And so, that kind of moves us to the full notion of a retrofit situation, where you're not junking the entire cabinet and bringing in a new unit and putting cranes up and disrupting the workflow of the building, where we can come in and do these retrofits. And so I know Waverly and Lou as well, you've been sort of project managing or certainly assisting on a lot of these higher level projects with these fan wall or fan array retrofits. So why don't you take us through some of what that involves and the bottom line benefits for our customers?
Sure. Well, when you would add a efficient fan wall and yank out an old 30, 40-year-old steel blower that was running on rubber belts, slipping, adding to dust, making the environment inside the air handler less hygienically stable, it just adds up to a situation that could affect your entire building. We love the idea of saving old equipment. And one of the ways that we found to do that is to actually put in a fan wall. We can come in at night and literally demolish the old blower system, install a new fan wall while your staff is home. This is after hours work usually. And the next day have your unit up and running and delivering airflow the way that it was, but more efficiently and at a lower cost for you in most cases. And it overall just allows your system to move up into the new age. These systems will be able to be BACnet capable. So if you had an old blower that did not tie into your front end system because it was lacking the controls, this is a one-step procedure that takes care of all that. It's ready for the future. It's into the future and allows you to bring some of your oldest equipment into the new age. And ironically, they just are more efficient. And it's not just the energy usage. When I talk about the efficiency, we're talking about something that literally has 0 to low maintenance. You're not replacing belts. You're not greasing bearings. You're not adding organic material for microorganisms to start feeding on and causing problems inside your air handler. It's really it's a no-brainer. And all this could usually be done at a fraction of the cost to actually replace the unit.
Yeah, we're seeing, and we have case studies where this could be 30 to 40% the cost. Where in this picture that you're looking at, with a tear out of the old insulation, new zero porosity fiberglass free insulation, recoating all the metal components, redoing the drain pan liner, cleaning the coils, 30 to 40% the cost of a brand new box, and with way less disruption to the facility. And again, I already mentioned the carbon footprint stuff, where you're not junking the old, bringing in the new, transport, shipping costs, cranes, the whole thing, spot cooling. So it's really a no-brainer. What I want to mention, at least with this picture, for some of you who have never joined us before or know about this technology, this is just one fan of an array of 5 fans. So we're just we took a slice of the picture here to show some of the other components of what can be done in this retrofit and restore situation. But the one thing of having multiple fans, Waverly and Lou, right, is that it creates a situation where one fan, if it should fail, the other fans will pick up the slack until the one fan that failed would be replaced. Is that right?
That is correct. There's a lot of redundancy built into the system. Where you got 5 fans like you're talking about, if you lose one, all these fans are rated way over than the regular initial design of the airflow. So you can take that fan out, blank it off, and have your system still run with no downtime while you're waiting for another fan to be replaced.
And as you can see in the photo, depending on the size of the fan, there's multiple sizes for the design of the system that is going to be retrofitted, but it's literally, 6 to 10 bolts. You take them out, it's a channel lock. You just plug and play, unplug them, slide it out. Like Lou said, put the plate in to cover the hole. And then when you do the lockout and tag out to bring the new fan in, you just slide it in, put the bolts back in, and you're up and running in no time. So again, it's like Waverly said, you step right into the future. And so with that, we're able to do all of this for you through our direct relationship to you. And if we oftentimes work with energy contractors to bundle into larger projects, these types of assessments and services. So the sky's the limit with getting us back to being able to be energy efficient with these systems as we move out of the pandemic. So I just want to thank everybody today for joining us. We're right on time. How's that, guys? And I just, I want to say a little bit about us, and then we'll open the floor to questions. I already see a few coming in. So last year, we were acquired by a much larger publicly traded company, as some of you probably already know, and that is RPM International, and we were put with the Trimco Construction Products Group. So now we are a service offering of Weatherproofing Technologies Incorporated, as you can see down there with our new logo, but it's the same old Pure Air Control Services. We were originally founded in '84, so we've been doing this a long time. We've seen a lot of units, a lot of conditions in buildings, and reported and fixed them all, basically. And so we have 3 specialized divisions within this suite of services, and building sciences is certainly where it starts. They're the frontline doctors, investigators, CSI crime scene investigators for indoor air quality and HVAC, and that's where Lou and Waverly work for us and go out and collect this data and make these recommendations. All of the samples go to WTI, Environmental Diagnostics Laboratory. And then when those 2 guys get done with doing all the reporting, those 2 divisions, we make those recommendations, and they're carried out by Building Remediation Sciences. Of course, we have 1 product division, Building Health Check, and they sell do-it-yourself test kits, localized air purifiers, which we didn't really talk about today, but in-room air purification devices, remote monitoring systems that are leave-behinds, and we can hook it up, and you can be monitoring the air quality 24/7 and reporting on it with some of these products. So all told, we've been in probably well over 900 million square feet and over 18,000 buildings in all this time. So again, you heard us touch on it: healthcare, education, commercial, a lot of government work, military bases, you name it, we've been in there. And of course, all of our respective technicians and field workers carry their industry standard certifications and affiliations and trainings that go along with it. So, again, once again, thank you all who have been in attendance today. Here's our contact information. Like I said, we covered a lot of stuff very quickly at a very high level, and we will always take the time to jump on a call with you if you want to discuss things on a more detailed level or through an email chain. So with that, I'd like to open our question tray up for any kind of questions. And we have a comment from JJ Baird, and he says, energy usage assessments, they're a very valuable tool with continued IAQ monitoring as part of an overall assessment. So he says this will help. So he's kind of confirming what we're discussing. We love it, JJ, as he says this will help determine where power is being wasted or is not used enough. So he brings up an interesting point, guys, about maybe systems maybe blower systems, right, that are underpowered, and how that can affect these recommendations being made by ASHRAE, to bring in more outside air. Have you guys seen that at times where something might be a little underpowered?
No, I have. You?
Not too much.
No, okay. A quick story. A long time ago, I actually noticed a V-belt system. And ironically, they did not have the ability to replace the belt that had broken on said unit. But they did have the ability to put a different size pulley, and did not know that there's a way that you can go negative or positive, or speed up or slow down depending on the size of the sheave or pulley that you change out on a unit. So in this case, they are underpowered or undersupplied their the space that the air handler was providing to make a belt fit. So when it was all said and done, the unit was not performing even though the belt fit.
Yeah, I mean, again, it's almost like that farmer's insurance commercial, right? We know a thing or two because we've seen a thing or two over all of the years. Oh man, that's good. So David Reynolds, again, our good friend and president of IFMA, has asked, how useful are digital simulations for planning, optimizing, and returning from temporary set points? He says they could be handy when your facility has a range of uses or with changing levels of operation and HVAC loads. So, what do you guys maybe know about running simulations as part of these assessments, or being able to use that for calculations?
Well, I know it happens. I'd like to have the opportunity to speak with more people. Is David, what's his name? Yeah, well, this is one of those circumstances where I'm sure we'd have something to learn. I know modeling is done. I'm not that informed on the ins and outs of the services, but that's an aspect that I hadn't thought of. So I guess I learned something today as well.
Yeah, we partner with different contractors a lot on controls, even though it's in our service name, Pure Air Controls Services. We generally don't do controls. So, which actually doves us into the next question by Victor Chalulu, and he says, do you guys handle or do you use a specific company to retrofit the air handlers? So generally, yeah, and Waverly, you can take this, but generally we're retrofitting, and then we're working with the constituency of building management and facilities management, and then their controls company that they contract with. Is that correct?
That is correct. Every single one of the retrofits that we start begins with an assessment of the unit, determination of how much airflow the unit is actually delivering. We always request the design intent, the original design intent for the unit, because we want to match that. That's what the coil was designed to handle. That's what the unit was designed to handle. So we want to make sure we don't go over our boundaries. So yes, design intent is always taken into effect, and we actually do the removal and we actually do the installation, and we're happy to partner with our most favorite fan wall manufacturer, and we've just been enjoying this this move towards the future, as I said, with these older units and saving them.
Yeah, so I mean, again, it becomes a group effort, with a lot of the trades that is coming together for this. But like you said, we're stepping into the future with it, and then because of that, you have quite a knowledge base working together that actually helps to troubleshoot more quickly and to be able to have this sort of install go more smoothly in the long run, because you have a lot of eyes on it. You have a lot of QA/QC happening all along the way from the various areas of expertise. David Reynolds actually corrects me. He says that he is the consulting council of IFMA. He's on the president of the consulting council of the International Facilities Management Associations, not the whole thing. And he gave me a smiley face. So yes, I'm sorry, I didn't mean to oversell you, but I know that you're integral in the education, David, and helping align facility managers with folks like us and other folks to make sure that they're doing the right thing at the right time for the benefit of their occupants. So we certainly appreciate everything that you do. The Consultants Council, yes. And then Chris Gonzlik, yes. Thank you for the compliment. He says, great presentation, and the recording will be available via a YouTube link. You should be getting that email on Thursday, if not tomorrow, with a link to the video and another link to the presentation deck. And yes, we'd absolutely love you to share this with anyone. And then even on that note, Chris, again, you see our contact information up. If you would like to give us to give this presentation, or any of you in attendance today, if you would like us to give this presentation to a select group at your organization, we would be more than happy to partner with you and set this up as a private Teams meeting or a private webinar to do this one-on-one with you, where we could maybe expand the Q&A a little bit or even tailor it to what you would want to have us talk about. So definitely feel free to email me if you'd like us to do a lunch and learn, a virtual lunch and learn, or something of that nature. We'd be more than happy to do it. So, well, guys, we're right at the top of the hour. Again, we'd like to thank everyone who hung in there with us, most of you. And again, stay tuned. In about a month, we'll be bringing you another IAQ Matters workshop. So on behalf of myself and Waverly and Lou, thanks, and we'll see you next time.
Thank you.